All right, this is lesson 14.1. So we've already been looking at quadratics and solving what my x's can equal. We use the quadratic formula, which is still written on the board, negative b plus or minus square root b squared minus 4ac divided by 2a. And we also used the box method to solve them. So now we're going to look more at quadratics and what they look like graphing. Now quadratics are when we have x squared in our equation. That's the highest exponent is a 2. That makes it a quadratic. So let's go ahead and look at this. A quadratic function is a function that can be written in the form of y equals ax squared plus bx plus c. Okay, we've already seen this form. We've been looking at it. While linear functions, now remember, linear function makes a straight line. Our quadratic's going to make a U-shaped, and we call that a parabola. Okay, so the name of this graph is a parabola. Using the word bank, label the parts of parabolas below. So we have different parts of parabola, and they're all going to become really important. So our vertex maximum is going to be this top part. So this is our vertex maximum. Because I am short on space, I'm just going to write max. Okay? It is the peak of the parabola. Okay? Now the reverse of that is if that's an upside down U. If we're looking at it like a U, we're going to have a vertex minimum. I'm going to abbreviate with the MIN, minimum. You can write out the whole word if you want to for your notes. Either way. So if my graph is facing downward, I'm going to have a vertex max. And if it's facing upward, opening upward, it's going to be vertex minimum. All right? Our axis of symmetry is going to be that line that splits my graph exactly in half. Now, you've talked about symmetry before in earlier grades. It's the same thing. It's the line that creates the symmetry. So that is our axis of symmetry. All right. And then our X-intercepts are going to be where they cross the x-axis. Now notice we have 2 of those. Because we have 2 places that it crosses our x-axis. All right. And then our last point is our y-intercept, and it's where it crosses the y-axis, y-intercept. Now, sometimes this will be our vertex minimum or maximum. Sometimes it'll be situated right there on that y-intercept, but not all the time. Sometimes it's off to the side like this. All right, the vertex is a minimum when a is greater than 0. So examples. So if a equals 1 or a equals 2, then the vertex is a minimum. But when our a is less than 0, so when a equals 1/2, nope, negative 1, negative 2, and so forth, then it's going to be a maximum. And remember, a is that coefficient before the x squared. It's that coefficient in front of my x squared. The simplest quadratic function is the quadratic parent function. Now that should sound a little bit familiar because we've talked about a linear parent function before. That linear parent function was the line that is y equals x. All right, so that should be familiar to us at some point here in that parent function. All right, so quadratic parent function, we're going to look at what that looks like. So we're going to start by we're going to start by making a table and graphing it. So let's start with negative 3. Now, our parent function is y equals x squared. I'm going to write it over here so it's with our problem. So when x is negative 3 squared is 9. Now, I'm just coming up with some x values just so we can see what this looks like. Negative 2 squared is going to be 4. Negative 1 squared is going to be 1. 0 squared will be 0. 1 squared will be 1. 2 squared will be 4, and 3 squared is going to be 9. Now notice we see a pattern here. We can see it's not linear because linear has a constant increase or decrease. Plus 2, plus 2, plus 2, plus 2. Versus we don't have a constant here, and we see a pattern. We see a pattern, but it's not adding or subtracting the same thing every time. All right, so let's look at our vertex, our x-intercept, and our y-intercept. All right, so I'm gonna go ahead and graph this. So our x value, -3, 1, 2, 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. -2, 4, 1, 2, 3, 4. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And it's going to curve just like the ones above. I have some students who like to do straight lines between each of these, but that's not correct. It's more of just a curved line, like a U. So when you connect those points, make it look like a U. I'm going to give you a couple seconds to get that done. All right, hopefully we're done by now. Since I'm not here, I can't really tell. So let's look. Do we have a minimum or a maximum? So if I can see that it's opening upwards, so it's going to be a minimum. But also, if I look, my coefficient to x squared would be a 1. Okay, and a 1 is going to be greater than, so we're going to have a minimum. I have a minimum here. So our vertex minimum was at the coordinate 0, 0, and it is a coordinate. I'm also going to put that it is a minimum. It's a coordinate, it's an x and a y value. All right, let's look at our x-intercept. Our x-intercept, this time we only have 1, and the reason we only have 1 is because my entire function is above my x-axis. It sits right on my x-axis. So that x-intercept is it passes right there at the 0, 0. Y-intercept is also 0, 0. We can see that in the table here. We know when 0 is across from 0. But also, because it sits right there at the origin, that's why it's 0, 0. Axis of symmetry. So where's the line going right between? Now I drew my graph looks wonky, but we can see that this is 2-way, this is 2-way, this is 3-way, this is 3-way. So my axis of symmetry is right there. And that axis of symmetry is our y-axis, but we're going to write it as a line, and it is x equals 0. It is a vertical line, so we know it's a vux, which means it's an x equals. Our domain, so let's look at our domain. Now just to remind ourselves, domain is our x values. Domain, if I look, this graph continues going up, and even though it's getting steeper up here, it's still going outward. So our domain is all real numbers. It's going to keep on going. All the x's. It can include any of these x's, left or right. It's just going to keep going. So if I look at this x1, yes. x2, yes. x3, yes. x4, it'll be way up here, and it'll keep going. But if I look at my range, this whole bottom half of the graph's not used. So that tells me that my range, which is my y value, is that y was only my numbers that were greater than 0. So y is greater than, or it can be equal to, 0. All right. Anytime someone has a question, if the sub would just pause this video, and if someone in the class feels like they know the answer to answer the question, then you can. If not, if someone will just write it down, I will be here before school tomorrow, so you can ask any questions when you get in here in the morning. All right, let's look at the back side. Oh, so just to refresh, that is what we call the quadratic parent function. It is our basic, most basic, simplistic quadratic it can be. Okay? So let's look at this one. Let's look in the back side. So we have a little bit different equation. We can see that there's more to our equation here. We have a plus 2x. We have a minus 8. So let's look at where our vertex is. All right, so just to remind ourselves, this is opening upwards. It's a positive, so we're going to have a minimum, and our minimum is right here. Okay, I am going to put that it's a minimum. And that coordinate is -1, -9. -1, -9. Is the vertex a max or min? We answered that already. That is a minimum. Our axis of symmetry. So let's look. Let's find some points. This is one away from this line. So our axis of symmetry, you will see it abbreviated a lot as an AOS, axis of symmetry. Here is our axis of symmetry, and if you want to put a dotted line to show it, if I were to fold the paper in half on that dotted line, the left and the right side would line up perfectly on it. So that is our axis of symmetry. So it is a vertical line. So it is a vux, which means it's an x equals, and it crossed at the -1. Our y-intercept, let's see, where does it cross our y-axis? Here's my y-axis. It crossed right here. So what is that coordinate? 0 and -8. Now don't get your axis of symmetry and your axes mixed up. So if you have trouble seeing that, this is when a highlighter or a matte pencil can come in. So I'm going to highlight my x and y axis. There's my y. Here's my x. Because I don't want to get it mixed up with my axis of symmetry. So if you need to do that, do it. Or if it's easier to highlight the axis of symmetry, then do that. If that helps you visually see it better, good. Let's look at our x-intercepts. So where's it cross the x-axis? We have -4, 0, and it crosses also at 2, 0. Okay, so that's where it crosses. Notice there are 2 this time because it did cross in 2 spots. Will it cross more than 2? No. This graph continues going on and on and on forever. The only way it crosses that 1 is when it is sitting on that origin. Will it ever be 0? Yeah. If my imagine this whole thing shifting above here, then I wouldn't have an x-intercept. I'm going to draw it lightly. Don't draw it on your paper. But if my graph is right here, sorry, I'll do it slow so it doesn't look like a blurry mess, then it's not crossing the x-axis at all, and it's not going to have an x-intercept. All right. Our domain, this is our x's. Let's see what's happening to our x's. In 0, yep, it looks like it's just going on forever, so it's all real. Most of the time, your x's are going to be all real in this case. Okay? Your y is where it gets a little trickier. So let's look at our y. So all of these y's are being used, but below here, there is no y's being used. Okay? So my y has to be greater than or equal to, and it looks like -9. Yep, -9. So it can be anything bigger than -9, but below that -9, we have no graph. I know some of you struggled a little bit with doing your domain and range. For what values of x does f of x equal -5? So remember, this f of x can be replaced with a y. So when will y equal -5? Okay, so I'm going to look at my -5. When will y equal -5? So here's y, -5. My x was 1. So here's my y, -5. And it crossed it at 1. So when x equals 1, it can be f of x will equal -5. And when it crosses at my -2. Oops, sorry, I don't think that's -2, is it? Oop, I'm looking at the wrong thing, sorry. Write it in my book. Here's my -5. I'm so sorry. I was looking at that circle. -5 is going to be -3. I'm sorry. Okay. All right, let's look at our last example here. You'll notice this time my function is opening downward. And because it's opening downward, we see a negative in our lead coefficient in that A spot. All right. So we will have a maximum point this time instead of a minimum point. So this is real life. If you imagine a ball, let's say that I'm this tall and I throw a ball upwards. It curves up and then it falls down. So we see a lot of this when we're looking at throwing objects, anything involving like gravity, pulling it back down to the zero. And that'd be if the ball fell to the ground, of course. So that would be a real life example of what this graph would look like. All right, so let's look at our maximum point. So our maximum point is right here. Okay, that's our max. And it looks like it's the point 4. And I'm going to say that's 125. It might be a little bit higher, 127. Okay, let's stick with 125. Sometimes it's not, we don't have that perfect little point given to us. What's the line of symmetry? So I can see that these 2 points both cross, and halfway between them is right here. So here is my axis of symmetry. Axis of symmetry. All right, so let's look at what that is. It's a vertical line, so I know it's x equals. For our cases, it will always be x equals. We won't be looking at any graphs that open left or right. So x equals, and it equals 4. So our line of symmetry, our axis of symmetry, is 4. Our y-intercept, where does it cross our y-axis? It crosses right there. I'm going to say that's, I don't know, we could say 48. I'm going to say 0.48. 48, 47, but that seems good. And here you're doing a little estimation. So on an assignment, as long as you said, 49, 48, 47, 46, I would accept it. Let's look at our X-intercepts. All right, so our first one is 9, 0. Okay, that one's easy to see. But here's the tricky. We know that that graph continues, but we're only seeing part of it. So how can I find out what it is? So what I'm going to do is I'm going to do a little sketch of it finished out. Okay? It's not perfect because I'm horrible at drawing these. Now here's our axis of symmetry. And that x-intercept is 1, 2, 3, 4, 5 side. So it's going to be 5 away on this side. 1, 2, 3, 4, 5, which would be a -1. So our other x-intercept is -1, 0. That is a little tricky because we didn't have all of the graph to see. But know that it's still going to continue going on. It even has an arrow showing us that it keeps going. Domain. Our domain here, all of our x values are being able to be used. So it is all real numbers. I know at one time some of you are having trouble drawing this. Guys, I do a parallel line. And then I draw an R with that outside line. Okay. For my range. Okay, the range. Let's look. So it looks like there's nothing above this. So I know that the y has to be less than or equal to, sorry, 125. I'm going to give you a little hint. This range coincides a lot with our maximum. Now, this is a maximum, so my y was less than. On the last one, when I had a minimum, it was greater than. Okay? So what is the best estimate for the largest value of x for which this function equals 80? All right, so we're going to look for our 80 here. Here's 80. And if I look, I have two values on 80. But it's asking for what's the greatest one. And we have a choice of 1 or 7. And 7 is going to be, when x is 7, that is our greatest. All right. All right, the sub is going to give you the assignment for 14.1. You're going to work on it for the rest of class. You have over half the period, hopefully, to still work on this. When you are, if you finish it, turn it in. If you have a question, circle it and move on. You may not work together. This is a solo act. You're working by yourself. If you have questions, I will be here in the morning. Get here early. Come ask questions. I'll probably spend the first 5 minutes of class saying if you have a question about one of them. But if you have questions over multiple ones, you're going to want to get here before school and ask questions. All right? Or you can come try to catch me later on in the day if you want to come ask me, stop me in the hallway or something. All right? If I don't see you later in the day, I hope you have a great day.